The DST-TEC has visited many industries and thereby collected industrial issues from various industries. On our website, we have enlisted more than 150 such industrial issues, and out of those, I will today represent 25 such issues. The very first industrial issue is the development of hydrophobic or waterproof cement, in which we require expertise from civil, chemistry, nanotechnology, material science, and physics, and other departments may collaborate. In this, we have seen that green algae grows on cement and concrete when surfaces stays constantly damp. It leads to poor bonding of concrete. The micropores in concrete further lead to faster growth of green algae. It reduces the life of structure and, due to its slippery nature, can cause various injuries. So the requirement is for developing the waterproofing cement. The solution approaches could be water repellent at particle level, reduction of capillary action, use of expanding cement technology, addition of organic polymers, improvement of surface finish, and the development of waterproofing layer or a paint. So one can add some film forming substance like oleic acid and molasses into the Portland cement for making it hydrophobic cement. The next industry technological requirement is the development of microfiber cement, in which we require expertise from civil engineering, chemistry, nanotechnology, material science, physics, and other departments may collaborate. In this, the visible cracks appears on the concrete structure due to plastic shrinkage or early drying. It decreases the durability of our cement concrete structures. Appearance of uneven surface, deformed structures are there, and we have to control the initiation and propagation of such cracks. Also, there is possibility of improving the surface finishing characteristics with the concrete durability and rust proofing of this cement. The deficiencies of all cement composites could be seen in terms of weak tensile stress, limited deformation capacity, and they need repair and rehabilitation from time to time. The most economical and practical solution is an overlay of cement composite, but it suffers the durability of pavement structure due to debonding and spalling. So for inculcating these shortcomings, the use of microfiber reinforced cement composite is suggested, where the microfibers are used having length of less than 10 mm and the diameters in the range of 25 to 40 micrometer. So microfibers are added to the Portland cement so as to become a microfiber cement. These microfibers could be either polypropylene, steel, carbon, or any other. And with the proper incorporation of these fibers, they can change the failure mode from brittle to quasi-ductile. The next industrial technological requirement is the development of low-cost special-purpose machine for the assembly of cloth clamps. The industry that we have visited is a small-scale industry. It uses manual assembly of the parts. It leads to breakage and surface rupture. Although there is an availability of machine, but it is very costly. And for a small-scale industry, there are also issues of break-even. So this industry requires a low-cost machine that is either automatic or semi-automatic. For solution purposes, there are available designs of those costly machines. There are available patented technologies, and there is also available research articles and available literature on this cloth clamp machine. So we can use that available technologies, available literature, and the designs in the development of a low-cost machine. The next industrial requirement is the development of low-cost special-purpose machine, in which we require expertise from mechanical engineering, electrical and electronics engineering, and others may collaborate. For identifying this problem, we had visited a gear manufacturing industry in which the gear was manufactured and the persons are doing grinding in a very uncomfortable sitting posture. They develop stress and fatigue and involves a very large unproductive activities. So in this gear manufacturing industry, there is evolution of extra material on parts during the drop forging process. The industry utilizes handheld grinding machine for this removal of this extra material. The labor is skilled and semi-skilled, but the sitting posture is very uncomfortable. The work environment, when we assessed for the sitting posture, it induces stress and fatigue to the worker. So there is requirement for the development of low-cost machine that is a part-specific grinding machine, which could be either automatic or semi-automatic. So for very first part, the proposed solution is in terms of a part-specific grinding machine having a vertical surface grinders. For part B, the proposed solution is in terms of a grinding wheel and a regulating wheel. The grinding wheel is having abrasive surface that grinds material off the part. The regulating wheel is having a control mechanism for speed and depth. There is a support blade that can support the component or the workpiece. The next technological requirement is in terms of industrial ergonomics for increasing the production. So we had visited a heater manufacturing unit that uses manual labor. They use assembly line, but the production rate was very less. When we analyzed the postural analysis with the ergonomic average, it defines an unstable posture that lead to the development of stress and fatigue to the workers, and there was a loss of productivity. The requirement is the use of industrial ergonomics for productivity improvement. As seen from the images, one can see that there is improper sitting arrangement of the workers that develops stress and fatigue in the workers, and there is a loss of productivity. The proposed solution could be in terms of improvement in workstation design, like micro motion time analysis, improvement in labor postures with the use of table rails, footrest, and the improvement in sitting posture with the combination of sitting and standing postures. These are some of the available literature for standing workstation design, for horizontal work ergonomics, and for the lifting techniques. The next industrial requirement is in terms of low-cost automation of an electroplating unit. So we had visited a small-scale industry for electroplating that uses manual winding of the part. Then the electroplating process is in progress, and the manual inspection was there. So it leads to less production capacity, quality, and productivity. And the effluent treatment is another essential for this industry. As seen from the very first image, there are the available fully automatic overhead conveyor that cost around 25 to 30 lakhs. But since it was a small scale industry, they require a solution approach in terms of I-beam monorail trolley conveyor that worth around 80,000 rupees. And there is a process improvement and quality improvement of the processes. The next requirement is for novel solution for bakelite waste, in which we require expertise from chemistry, chemical engineering, mechanical engineering, civil engineering, material science, and others may collaborate. Bakelite is basically a phenol formaldehyde, which is a thermosetting plastic. It is a good insulator, and it is used for non-conductive parts and electrical devices such as radio parts, sockets, wire insulation, switches, clocks, buttons, washing machine, toys, and kitchenware. The limitation of using this bakelite is, since being a thermosetting plastic, it hardens upon hitting. Once they have set, one can't melt them. It is also impossible to recycle, but yes, they can be reused. So we had visited a large-scale electronic industry that generates about 2 tons of bakelite waste in an year during the injection molding process. The image shows the injection molding of the part. The final part requires the removal of extra material, which is the bakelite waste. So we have to reuse this bakelite waste for replacing the natural fine aggregate in cement mortar, recycling waste bakelite as a carbon resource in iron making process. Bakelite waste particle boards could be formed. So these are the available literature for using this bakelite waste. The next industry technological requirement is in terms of low cost control of noise and vibration, in which we require expertise from vibration and acoustic, mechanical engineering, industrial engineering, and other departments may collaborate. For assessing this problem, we had visited a gear manufacturer industry that uses draw forging for manufacturing of large gears. The process is associated with huge vibration and noise. The earlier setup is having some coil springs that reduce the machine vibration, but with the continuous hammer operation, it reduces the spring life. The effect of vibration could be seen as an adverse effect on workers and the neighboring residents. So there is need of vibration surveys, soil assessments, and pit designs. As seen from the image, it is an image of draw forging process in which huge amount of vibration is created. And the second image shows the spring support systems. The proposed solution is in terms of the use of helical steel springs and the viscous fluid dampers. So we require expertise to make them. The next industrial technological requirement is for the remedial solution for metal chips. For assessing this problem, we had visited the same gear manufacturing industry that produces a variety of metal chips during the machining process. The problem identified was that these chips are having more volume as compared to its less weight. The chips have also an added lubricant to it. When the scrap vendor comes, he always complained about the weight mismatch. Further, the vehicle operators, they are not ready to transport these metal chips due to its large volume as compared to its less weight. Further, this metal chips yield more slag and less metal, and they are the major source of jamming of conveyor also. So these are images that deal with the metal chips scrap. And the proposed solution could be seen in terms of a metal chip compression machine or a metal chips grinder or any other proposed solution from the experts. The next technological requirement is for image processing for inspecting the parts dimensions. For assessing this problem, we had visited a bicycle manufacturer industry that uses the manual inspection of each and every part of their industry. So they require accurate and timely information, and there is a requirement of digital image processing or automatic visual inspection, such that the automatic detection and rejection of faulty parts could also be made. So we require a low-cost image processing technology such that the automatic detection of faulty parts and automatic detection of these faulty parts could be made. The next industrial requirement is for automatic and semi-automatic solution for pasting of adhesive and water stickers. For assessing this problem, we had visited a bicycle giant. The process involves the manual pasting of stickers on the bicycle parts, and they require some automatic and semi-automatic pasting of these stickers. The next problem is related to finding the depth of fusion or depth of welding, penetration depth of this welding. So it requires some software tool. The initial process, the earlier process uses nitric acid. When we pour nitric acid onto the welded area, they give different color shade corresponding to different materials. So we require some non-destructive testing for finding this penetration depth. Some software tool or mobile application can be made that automatically measure the area of fuse part and give a numeric value that is indicative of the weld depth and the penetration depth. The next problem of industry is for effluent treatment, and they require solution for salt and color removal from textile effluent. As seen from the images, these textile industries are the major source of contaminating our water bodies with color and salt. So they require some solution or technology for removing the salt and color from this effluent and make it reusable again for similar or some different applications. The next problem is related to IoT-based fluid level indicator. The problem arises out of a industry that collects effluent from various other industry. So it requires some IoT-based solution for analyzing the quantity of fluid from each industry. Further, this same technology is the requirement of additional sectors like refinery and chemical industries, energy and power plant technology, feed water heaters and boilers, oil and gas industries, offshore exploration and drilling, pipeline compression application, pulp and paper, food and beverage, gas plants, and pharmaceutical industry. The next industrial issue is related to human activity, and this is using image processing or artificial intelligence. This is the problem of industry that uses the manual operations for making their parts, and the process involves specific movements of hand and feet. So they require some cameras such that they will capture the images of the workers. These are basically motion sensing cameras. They need an image processor such that they will analyze the specific movements or activities of the labor, and one can see the chances of improvements for the unproductivity such that they could eliminate the unproductivity activities of the workers. The next problem is related to automation for lifting the hot plates from the furnace. There is an industry that is involved in the agriculture equipments and parts. The workers are lifting hot plates with the help of lifting thong. So they require them process of automation for lifting these hot plates from furnace and placing them directly below the tool for forging. The next problem is related to increased solubility of insecticide in water. So there is an industry that is manufacturing pesticides. They have a problem of faster precipitation rate of these pesticide, and the pesticide and insecticide is causing etching also. So they require solutions such that the technology can increase the solubility of pesticide and decrease etching. The next technological requirement is for the development of automatic and semi-automatic machine for the development of forks and mudguards of bicycle. Basically, they require automatic or semi-automatic machine for the color lining of these bicycle parts. Initially, what was happening is the manual operation is involved. They require high-skilled worker with a simple customized tool. The next industrial issue is related to the automation required for finishing of bicycle mudguard. This is the problem of the same industry. For the final finishing of bicycle mudguard, they are utilizing the manual operations, and it also requires high skills and accuracy. So automation is required for any of the process or all of these processes. These are the 4 different processes involved in the manufacturing and finishing of bicycle mudguard. That is sticker pasting, install monochrome, punching, and packaging in polythene. The next industrial issue is for automatic sorting of parts. The parts containing any defect or scratch, discoloration, and dimensional inaccuracy should be automatically get sorted. The part weight is about 30 grams and the maximum dimension is 5 centimeters. So they require some solution in terms of PLC-based sorting, image processing-based sorting, or any other customized feed tray and sieve-based automatic sorting of parts. The next industrial issue is for the segregation of printed packaging boxes. It is a problem of a packaging industry that require automatic machine to segregate the printing boxes on the basis of their color and misprinting matter. The task is being presently done manually onto the printed boxes, and they require some automatic sorting of parts and for quality control, and they require image processing or artificial intelligence based problem solving approach. The next technology requirement is in terms of low cost automation required for stripping of extra material of the parts. It is a problem of packaging industry that require low cost automatic machine to stripping off the extra material of the printed boxes. The task is being presently done manually, and they require some automatic low cost machine for this task. The next problem is related to increase the setting time of concrete. It is a problem of a MSME unit that prepares mixture of sand, cement, gravel in proportion. They transport this mixture to the actual work site. The material is carried with the use of these large containers as mentioned in this figure. At the actual site, the mixture is being poured before 3.5 hours. The problem is they sometimes the actual work site is far away, so they require the setting time for concrete. They wish to increase this setting time of concrete from 3.5 hours to 4 hours. The next requirement is the development of small dynamo as a bicycle accessory, in which we require expertise from electrical engineering, physics, material science, mechanical engineering, and others. The problem is identified at the industry of a bicycle manufacturing industry that wish to develop small dynamo that is operated by a pedal, and the electricity thus generated can be used to charge a battery, and the battery may further be used as a mobile charger. The next requirement is for finding the thickness and hardness of paint. It is the problem of a paint industry in which the paint is applied to the metallic part, and they can't assess the thickness of this paint and hardness of this paint. So they require some solution such that they could quickly find the thickness and hardness of the paint that is applied to the metallic part. So these are the some of those 150 plus issues that are mentioned on our website. For more details, you can contact DST-TEC of Panjab University. That is the Technology and Living Center. It is in the old DCC building near State Bank of India of Panjab University, Chandigarh. And you can feel free to contact at any time.